Hey, boys and girls, welcome back. Today is Wednesday, and it is our 7th day of Number Corner for January, and we're going to do a lot of talking today about angles, the measurement of angles, and we're also going to do a lot of work with observations. So we're going to have to really use our math brain to think about what's going on, because today is the day we finally get to figure out what our pattern is in our calendar grid. Before we get there, though, let's go ahead and spin for our calendar collector today to see what we got. We only got 1 degree. 1 degree. So if I were to add that to my circle here, I know that it's going to be really hard for me to show 1 degree, and maybe I can only do it with drawing a line because I am now at 121 degrees. So I have collected 1 degrees, and that is one 1 degree angle, which now gives me 122 degrees, and we know that it is an obtuse angle. But I want to introduce another vocabulary term for today because we may need it when we're talking about our calendar grid observations. So here are some vocabulary terms that we've learned so far or reviewed. We have the zero angle, which means there is no angle at all. We have the cute little angle, means it is less than 90 degrees. A right angle, which means it's exactly 90 degrees. Obtuse means it's greater than 90 degrees, but now we're going to fine tune that just a little bit more because it's greater than 90 degrees, but it is less than 180 degrees, which would be our straight angle. So if a straight line that goes right up and down, then the angle that is formed, like right here, either on this side, or we can even think about the angle on this side, that is 180 degrees. And so obtuse is only between 90, greater than 90, and less than 180, because 180 degree angle has its own special name. Now, when you get bigger than 180 degrees, this is what we call it, reflex angle. Can you say reflex angle? Now say it really fast 3 times. Reflex angle, reflex angle, reflex angle. Great. Sometimes when you say things 3 times, usually it then becomes a part of your vocabulary. And that's what I'm hoping for today as we observe what's going to be happening or what's already happening with our calendar grid. So, reflex angle, more than 180 degrees, less than 360 degrees. Are you ready to talk about calendar grid? Let's do it. That means you also need to remember some of these things that we've talked about on this page, or consider it. 1/4 of an angle is 90 degrees. 1/6 of an angle we found out is 60 degrees. And we found that out because 360 divided by 6. Simple. We got 1/12 of an angle is 30 degrees. And then we also talked about 1/8 of an angle, which is 45 degrees, because it's a half of a quarter. Half of a quarter is 1/8. So let's get started with our calendar grid observation chat. Here we go. Before I reveal today's marker, let's simply start off by looking at our calendar grid pieces starting from day 1. And when we do that, we're going to be filling out this recording sheet. So you may want to take a look at this recording sheet really quickly to know what all it is we're going to be doing. I'll give you a moment. All right, so we're naming angles. We need to figure out how much they measure. And we got to write an equation, right? And definitely some observations as we see necessary. So, starting with day 1, and I'll make myself just a little smaller here so I can click, no problem. So here's day 1. Do you remember what that looks like? Let me make it a little bigger for you. And I'm going to bring it forward. All right, what does that look like? We just reviewed our vocabulary terms. That is a 0-degree angle. Now, when you also look at this, I know we kind of talked about this when we first looked at our calendar grid, but it kind of reminds you like a clock, right? So we have a ray here, but essentially we have two rays, one on top of the other, and one of them is going to keep moving as our calendar grid progresses throughout the month in order to reveal the pattern that is being created. So we're starting with a 0-degree angle, and 0-degree angle we know measures 0 degrees. 0 degrees. All right, do we need an equation for a 0-degree angle? No. If I were to make some observations, I might say something like, it reminds me of 12 o'clock. Because really it does. It looks just like it would if I were talking about a clock. Because a lot of times when we're talking about angles, we're referencing an imaginary circle, if you will. Kind of like what we use for our calendar collector. And that circle can be like a clock because one arm is moving around. We good for the first day? Our 0-degree angle. All right, now we're going to have to figure out what angle is, what day 2 is all about. So let's look at day 2. Day 2. Let's make this bad boy a little bit bigger, just like we did the other one. And what do we have here? It looks like it might be like, what, 2 o'clock maybe? Now, here is going to be our challenge. Well, let me back up. First, let's name it. What is the name of this angle? Yes, it's so cute and little. So I'm going to put, it is an acute angle. And I'm not going to write angle for each one, but we know it is an acute angle. And let's make sure all of these match because that would bother Miss Trammell if they don't match. Okay, so the question is now, how in the world am I going to figure out what it measures? Which is why I reminded you about what we realized earlier this month, essentially, when we looked at our collector grid, or our circle here. So if we said that our angle looks like it's about at the 2 o'clock mark, if I were to have to label this in terms of time, my 90 degrees would be, and I'm doing this because I don't have a protractor to show you on the screen how to measure the angle. I wish I did, but I don't. So we're going to have to make some connections about things that we've already talked about in order to figure it out, and I think we can do that. If this were a clock, this would be 3. So imagine splitting up 90 degrees into, let's say, three different sections. If we were to do that, we would get 1 o'clock at 30 degrees. It would be my 1 o'clock, which would mean 2 o'clock would be here. Now, originally, Ms. Trammell said that this looks like it's really close to 2 o'clock, but it's not. It's not close to 2 o'clock, and it's not quite as small as 1 o'clock, which means to me, maybe it's in the middle. So let's take another look at it. Here it is. Here would be about 1 o'clock, and here would be 2 o'clock. So if it's kind of in the middle, maybe closer to 2 than it is to 1, I'm going to tell you, just because this is really hard to do virtually, I'm just going to go ahead and tell you that this angle is supposed to measure 45 degrees. And maybe once I tell you that, you'll realize when you're looking at it, like, oh yeah, that does look like this. Watch what I'm going to do here. If I were to take, and this probably would have been a better thing to do than what Ms. Trammell was trying to do. If I were to take, trying to write on my piece here. If I were to take my straight line and go ahead and represent my 90 degree angle, then you can see that this is half of 90 degrees, right? Okay, so we got 45 degrees and not really an equation. And we can say, observation, it's half of 90 degrees. So maybe I should have done that before I thought about the whole clock thing. But you live and you learn and you keep it moving, right? So that's what we're going to do. Let's look at day 3. Let's look at day 3 here. Oh, that's easy, right? What kind of angle is that? Yeah, it is a right angle. So I'm going to name that angle. It's a right angle, and a right angle we know is measured 90 degrees. And if I were to write an equation for this one, what could I say? 90 degrees is what? 45 plus 45 gives me 90. Perfect. Or I could even be really fancy and say 45 times 2, because that's exactly what I did. We're going to keep moving for the sake of time. So buckle your seatbelts and move with me. So we've done day 3 here. Let's look at day 4. Anybody noticing a pattern yet? Maybe not yet, but maybe it's becoming clearer to us. So if this were my day 4, and I don't know why I could write on it with this pen, but not with this pen. Let me try this one. That's interesting. Well, needless to say, if I were to try to use my benchmark of knowing 90 degrees, here's 90 degrees right here, and it looks like I have another angle that's measured about the same size as my angle from Tuesday, which means I have an angle that is, right, we can name it. It is obtuse, you're right. It is an obtuse angle, but if it looks like it's the same size of 90 plus one of these, what would my equation be? Or what's my angle measurement? Yeah, 90 plus 45 equals something. What is that something? 135 degrees. I could also think about it as saying 45 plus 45 plus 45, right? So now I know my angle measures 135 degrees. Are we good? Now, let me fix this as well. Okay. So what do you think our pattern is right now? What's happening? It looks like we're adding how much every day? Looks like we're adding 45 degrees each day. Let's see if that holds true. Here's day 5. Oh my gosh. What do we have? What kind of angle is it? Yes, it is a straight angle. Now, we know what a straight angle should measure. We think, so that should measure 180 degrees. We think that our pattern is adding 45. So let's just make sure that 135 plus 45 gives us 180. Does it? Yes, it does. And how many sets of 45 degrees do we have in each one of those? How many 45s are within 180, I guess is what I'm asking. We had 3 45s on February 4th, which means we're adding a 4th 45. So I'm going to do 45 times 4, which is going to give me 180. Straight angle. Reminds me of 6 o'clock, right? If we're talking about clocks. Okay, so now we see that it does look like we're going by 45 degrees. If you didn't notice that, hopefully now you see that. And now we have a chance to name an angle that we hadn't named before, but I told you at the beginning of this video, starts with an R. What kind of angle is it if it's more than 180 degrees? Yeah, it is called a reflex angle. So we got 0, acute, right, obtuse, straight, reflex. I wonder if there's a pattern there. Maybe, maybe not. So if our pattern is adding 45 degrees, what should this angle measure? It should be 225 degrees. And I know I'm adding another 45, so I could say 45 times 5 gives me 225 degrees. So what do we guess the 7th is going to look like? Yeah, it looks like 3/4 of our way. 90 degrees plus 90 degrees plus another 90 degrees. Or 90 times 3, which is 270 degrees. Perfect. Do we still call it a reflex angle? Yes, we do, because we are measuring like we're going around the clock. So we're not going to automatically start this way. But if you looked at that and knew it was 90 degrees, that's okay. But you got to think about it's 90 degrees less than 360 degrees, which is a full rotation. So here's my reflex angle, which is 270 degrees. And I know that's the same thing as 45 times 6. And 45 times 6 is 270 degrees. If I were to make observations, I could say it's 90 degrees away from a full rotation, which it is, right? Okay, now let's look at the 8th. Uh-oh. Let's try that again. Let's look at the 8th. We're getting closer to a full rotation, right? So we have another reflex angle, and that reflex angle is 270 degrees plus, what's our pattern here this month, so far at least? Yeah, adding 45 degrees. So 270 degrees plus 45 degrees is 315 degrees. And that's the same thing as 45 times 7. Or maybe, for this one, I should have written, can anybody think of what else I could have written, thinking about our 90 degrees that I said? How many sections of fourths do we have with our picture here? Yeah, it could have been 90 times 3, and that would have given us the exact same thing. Okay, moving right along. Here we go, the 9th. Oh my gosh, we have another what? We have another straight angle. Or, I shouldn't say straight angle, my apologies. We have another 0 degree angle. What? Now that I'm looking at this, I'm thinking about it in a different way. It can't be a 0 degree angle, right? We have made one full rotation around our imaginary clock or circle. So guess what we're going to call that? That is a full angle. We have completed a full rotation, full angle, which is measured 360 degrees. And we know that we could say that's 90 degrees times 4, because 90 degrees is 1/4 of an angle. We could say it is 45 times 8, because we have 8 of those. We know 45 degrees is 1/8 of a full rotation. We could even say 30 degrees times what? What was our fractional piece for a 30 degree angle? Was it a 12th? So it will be 30 degrees times 12. We could say so many different equations for this full angle. It makes me wonder about, what is today's calendar marker going to look like? Well, guess what? We are about to find out. But first, please make a prediction. What do you think it's going to be? Let's see. Are you ready? I am. What in the world is that? Did it blow your mind? It blew mine. I thought we were going to go around again, but maybe change our pattern. Once we made a full rotation, maybe we'd be doing 30 degrees this time. But this This looks very interesting. What do you think about it? Well, what do we know it's called? It's not a ray. It is a, let's go back to our vocabulary terms really quickly. It is a line segment. That's what it is. It's a line segment. I wonder what that's going to mean for the rest of the month. I will go ahead and tell you that our pattern is changing. It's changing. And you, my friends, are just going to have to stay tuned to see how it's changing. So, until next time, you guys have a great rest of your day. I'll see you tomorrow.